Jai Hind to all. It gives me immense pleasure to extend you a very warm welcome on behalf of Faculty of Engineering and Technology who has clubbed all of us for the webinar Current Trends in Research and Innovation. I, Dr. Nisha Rana, Assistant Professor Zoology, Swami Vivekananda Bharati University, on behalf of Organizing Committee, welcome Chief Patron Dr. Atul Krishna Sir, Founder, Swami Vivekananda Bharati University, patrons of the webinar, Honorable Vice Chancellor Sir, Professor Major General G.K. Thabulia, Sir, Honorable CEO, Ma'am, Dr. Shaliraj, Chairperson of the webinar, Professor Dr. Shravan Gar, Vice Principal, Faculty of Engineering and Technology, Co-Chairperson Dr. Nikhil Rathi, Head Department of ASH, all principals, deans, HOI, HODs, scientists, participants, faculty members, and students. I also welcome our speaker, Dr. Sushil Saraswat, postdoctoral USA, PhD, IIT Delhi, Professor and Head, Chemical Engineering Department, MBM University, Jodhpur, and Dr. S. Shaktiwal, DGM Technology Group, Tata Consultancy Engineering Limited, Mumbai, India. Jai Hind to all. Before I start further, I would like to introduce the webinar. The webinar is focused on recent advancement in field of technology and innovation. The aim is to gain deep understanding of research field and leading expert globally with the trends modules. Now, I would like to introduce and invite Honorable Vice Chancellor Sir for his welcome address. Sir, please unmute your mic. Jai Hind, sir. Sir, please unmute.
Jai Hind, Dr. Nisha. Okay. Have you
Yes.
finished?
Yes.
Okay.
Yes.
Jai Hind and good morning to you all. It's a great honor to speak on this inauguration of One Day National Webinar, which is being organized by Faculty of Science, Research and Development Center and Faculty of Engineering together. And I thank the Faculty of Engineering, Faculty of Science and Research and Development Center for the same. This is the need of the hour. We must discuss how we can improve our research ecosystem in the university. Because unless we have an improved ecosystem in the research, we cannot go ahead. It's a mandatory. So there needs to be change of the mindset in every faculty's mind. Faculty is not only the educator, they are the researcher also, they are the mentor, and they are the team leader. So these four qualities, if one has, then only he becomes a perfect faculty member. I'm sure with this kind of a deliberations and this kind of a webinar, we will be infuse that mindset in the minds of each faculty that their role is not only to teach, but their role is also to do research. And not only their own mind, they will have to infuse this analytical thinking in the minds of these students. So those students who are in the learner today, when they become educator tomorrow, they are equipped with both the skills of educating as well as doing research. So I'm sure this webinar is going to be a very, very successful, and I wish you all the best for the same. And all the participants of this webinar definitely will gain a lot from each other, and they will make their strategy in future how to become a good researcher. All the best. Thank you and Jai Hind.
Thank you, Sir Jai Hind. Thanks for your motivating words. Now, before starting our first lecture, I would like to introduce our first speaker, Professor S. Shaktiwal, Deputy General Manager, Technology Group, Tata Consultancy Engineering Limited, Mumbai, India. Sir has completed his PhD in Chemical Engineering from IIT Delhi. He is having experience of many administrative posts, including experience in Tata Consultancy Engineers Private Limited, Senior Specialist Engineers, Manager Process, TCE Qatar Science and Technology Park, Doha, Qatar, Senior Manager, Assistant General Manager, Sir has managed major research projects including clean India energy, chemical energy, renewable energy, and waste of energy and water, including zero liquid discharge projects, wastewater treatment using membrane bioreactors. He has been served as mentor, research industry mentor for research consultancy project synthesis and characterization of silver nanoparticles and applicability of removal of heavy metals from contaminated water by in Doha, Qatar, with the fund of more than 60,000 US dollar. Sir has been served as advisory board member for School of Engineering in University of Petroleum Engineering Studies, India. Sir has also received many awards including Technical Excellency with Professional Ethics Award and Organizational Individual Growth Award. Sir is also a member of many professional associations including Indian Institute of Chemical Engineers, Institute of Engineers. Sir is also a reviewer of many reputed journals and also published more than 25 national and international papers and 15 international magazines. Now, I would like to invite Sir to deliver his talk.
Good morning. Thanks for introductions. My name is Shaktivel. I'm now working in Tata Consulting Engineering. I belongs to technology team groups. So today I have to thanks to Subhatra Universities to arranging wonderful webinar, which is need for right now. We are having a technology day-to-day life is changing. So we want to understand that what technology to change, how to adapt, at how to the mature level you want to done. So today I'm going to talk about there are plenty various technologies are emerging, including artificial intelligence, digital drones, and everything. As a chemical engineering, today I'm going to talk sustainability as related things. Today, everybody is talking about climate change, but we have to change and act before that worst conditions. So we want to create our environmental to be sustainable. Our environmental means is a industrials to be sustainable. So today I'm going to talk about current trends in research and innovations. The national today topics on current trends and research and innovation. I have changed little bit current trends and technology and innovation, innovative opportunities in energy transitions. So here today I'm going to talk about the key approach for energy transitions, energy interventions, key futures of technologies, takeaways. This is my appropriate content for today presentations. I'd like before going to presentations, I'd like to see the what is the energy transition. Should understand here. What is to be transitions? We can currently we are all industries based on heavy oil, heavy fuel oil, carbon based fuel. For example, natural gas, coal, or crude oil, so that all the carbon based resource be converted as a fuel, whether it's a transport fuel, diesel or petrol, or industrial feedstock, or industrial power generations purpose, or stationary purpose. So currently all our energy system running from carbon based fuels. Suppose if you want to shift this carbon based to clean fuel, you want to identify the what are the routes to be available for that replacing of carbon exiting. So what is the motivations for the energy transitions? For example, the climate change mitigations, we want to do the currently we are experienced everyone experiencing about the climate change. So that's to be a mitigation to be done by energy transition, long-term energy securities, price stabilities due to that geopolitical issues. So we are getting the price stability is happening. National security also one of the key driving factor for energy transition. Economic opportunities for domestic. These five key parameters enabling the energy transition for the another way of approach. Here, the key approach for energy transition. Now we understand the energy transition. What is the energy transition? What are the key pillars? What are the key pillars for the energy transition? For example, right now we can say increase the energy efficiency or existing energy system. One of the opportunities to reduce that our existing carbon fuel, Or another way, increase that renewable energy, for example, solar, photovoltaic, or wind energy, hydrothermal. This kind of energy if we increasing, then carbon fuel will be reduced. Then we have currently our electricity generation method based on the coal-based, thermal based, or natural combustion based. So we should be a shifter to zero carbon technologies. Then, for example, other cement industry, refineries, steel industry, they are plenty of oil or process natured carbon emissions happening. That could be captured. That is another way. Biofuel, yes, one of the approach with carbon capture, one of the way to shift the carbon emission. All electrical vehicles preferred compared to conventional IC engine with conventional fuel, diesel or petrol. Shift to clean energy as a hydrogen. These are the key pillars, key approach for energy transitions. Next, you can see next slides. I'll show you here. This is India target. Suppose whenever we are doing for research or in contribution, we have to understand what is the current problem, what is our target, then we can initiate our research. That is the three things we have to look about. Already last two slides, we have seen about what is the energy transitions overall, then what are the key pillars, and the key pillars according to the what are the Indian targets. So, as per the Indian targets, India 2030 decarbonization target was announced in COPs 26. The highly ambitious goal includes decarbonization energy to 50 percentage, achieving 500 gigawatt of fossil fuel free generating capacity by 2030. These are the committed targets, but right now we are not near to this target because of. I will explain the previous other slides also how we are doing. So we need non-fossil fuel energies around 500 gigawatts by 2030 to meet 50 percentage of energy requirement till 2030 with the renewable energy. So 5 million tons per annum of green hydrogen needed by 2030. So reduce the project carbon capture by 1 billion tons per 2030s. And they reduce the carbon intensity of economic by 43 percentage by 2030 to achieve the net zero ambition of greenhouse emission by 2070. This is all the 6 targets India committed to the COP 26. Suppose if you want to achieve these goals or things, we need a massive research and collaboration and industrial implementations we needed. So based on that, this motivation, based on that, so we will go one by one. What are the how to achieve these things? So energy transition, now I'm dividing what are the technologies available for energy transitions. For achieving this above previous slide, I showed the target, how we can achieve, what are the approaches will be there. So this is the approaches we can consider as. First of all, approach is renewable energy. For example, solar, wind, nuclear also one of the considered as a clean energy. Energy storage, batteries, pumped hydro storage, compressed air, green hydrogen, yes, water electrolysis, smart grid, electrical vehicles, energy efficiency technologies, CCUs, then advanced nuclear power like a small modular reactor, biomass with a CCU, gasification, pyrolysis, translocation. See, this is the first column. It shows the approach. Second column shows the technology intervention. What are the technology they helping to us to the moving for further to energy transition. In this, if we are understanding this approach and the energy intervention, now we'll go by one. This is for example, we can say the solar energy. See, if you understand the first slides too, so next 10 slides I'm going to show in this fashion. First, understand the template of these slides, so easy for track me. You can track me also. First is the technology. What are the technology currently? Cell technology or panel technology. There are cell technology, silicon, So most of the solar cells is developed by silicon, commercially is available. Thin film also it's available. Perscovite is under research. Some of the universities are developing also at commercials. It's not at the commercial stage. Solar panel, we can say the another technology is monocrystalline panel, polycrystalline, thin film crystalline panels. So in these things, monocrystalline, you can see wherever you can see the solar panel, it looks like a blue color. That is solar monocrystalline panel. Polycrystalline also there will be there. Black lettered might be black color will be available in the market. So current trend of advance, what are the trends they should understand in this technology? First of all, technology to be understand, what are the trends and advancements here? So increasing efficiency usually improve with the research and development efforts focused on enhancing light absorption, reducing energy loss, and exploring new materials. This enables more electricity generation from given surface area. So another method is bifacial panels. See, these bifacial panels capture the sunlight from the both sides, maximizing energy generation by utilizing reflected and diffused lights. Bifacial panels are gaining popularity, especially utility scale installations. So these all the trends, for example, tandem solar cell, improved durability, longevity, integration with storage, they all the terminology having lot of potential to be done for research. This is currently is trending this technology, along with its need a lot of research approach also. For example, the tandem solar cell combine multiple layers of different material with the complementary absorption properties to achieve higher efficiency. For example, Perscovite silicon tandem cells have demonstrated the potential to surpass the electricity limited for individual solar cell technologies. So these kind of things to be understand as a research perspective, even OEM, those who are want to willing to prepare that kind of solar panel, they want to understanding this. Then what about our status of current status of India? So this is you can say second row and second column, that box showing about what is the demands. Actually, our target is already in the first slides. We explained about 500 gigawatts of installed renewable energy by 2030. This is targeted. Right now, we are getting 280 gigawatts solar power, 140 gigawatts wind energy, hydro and others is there. As recent data showing about solar is here as additionally to be involved here. This is a 280, 140. This is for a the summation of so what 500 should be there. But current situation of solar power, only 66.7 gigawatt only installed. This much gaps is there. Only remaining 7 years we got to reach these two 666 to 280 gigawatts. That is our target. So we need enormous efforts and increase the efficiency. Right now, industrial efficiency, for example, I can see the third row of box and middle box, the efficiency. All the industrial efficiency, monocrystalline is showing 20 percentage, maximum polycrystalline is coming 13 to 16 percentage, GISC is coming around GI means copper, indium, gallium selenoid. That is another thin film, maximum 35 percentage. This is under development only, not commercialized. Suppose if you want to put that the major material requirement, you can see the glass this much 70 metric tons for if you want to develop steels this much 56 tons required, copper, platinum, plastics and aluminum, silicon. These are the material requirement to develop. Yeah, if you want to 1 megawatt, if you want to produce a 1 megawatt, if you want to manufacturing a solar panel, this much of energy. Recent innovation might be recently there was already mentioned like Perscovite solar cell and the quantum data solar cell utilizing semiconductor nanocrystalline. These are the recent 10 for this solar cell related things. it's booming like that. We are expecting to the efficiency around the 20 to 38 percentage from 19 percentage. It is the best for industrial purpose. Next is for your wind energy. I'm talking about the wind. We can similar way technology onshore wind and offshore wind and floating windmill is there. Types of you can say vertical axis windmill, large three blade horizontal axis. These are various type of turbines. Also, we can use it for a technologies. Current trends for that windmill, larger turbines, improved efficiency, the floating wind technology. These are preferred current technology. So a small windmill may not give that much of efficient operation. So that is a preferred larger turbines, improved efficiency on that one. And the floating wind one also we are preferred. And the integrated energy storage, digital and remote monitoring, enhancing efficiency. This is a current technology for the wind. Currently, if you go there, as I said, 140 gigawatts is a proportion for a 500, but right now we have only 42.8 gigawatt. This is our current status. But however, we have a lot of opportunities to be increased that proportionalities in as soon as possible, because of already many projects are under constructions or engineering stage. So in 2030, we hope we can quite good we reach around 500 gigawatt. We have hopefully. So the recent innovation, we can see the bladeless turbine has been slowed to booster efficiency level as a high 60%. See, blade, it means usually windmill having a blade. So one of the recent research is talking about bladeless turbines. Its efficiency is a 60%. See, when that is one more interesting information person. That's be focused on that wind and energy. Next is batteries. Batteries, as you know very well about, there are several batteries we are industrials we are using backup powers. So here superconductors, pumped hydro storage, compressed air storage, flywheels, thermal energy. These are various technologies for energy storage. But currently we are talking about only for batteries. I'm not talking about other superconductor, pumped hydro or hydrogen flywheel. I'm not talking here. Here I'm selecting about storage, energy storage as a battery. I'm considered here. The type of batteries we can say the lithium ion batteries we are mostly we are using. Solid state battery also, flow battery also. Three type of batteries we are currently available. But the current trends on here is lithium ion batteries are the one of the trending, but we need a higher capacity device. We need which has a higher capacity device, but we need a furthermore capacity device. It includes developing new electrodes material, silicon anodes, high capabilities, cathodes, and optimizing electrolytes compositions. These are the trends. Enium, along with it, you can say that if you go for that India demands, India will have the battery storage potential of about 600 gigawatts hour by 2030s. This is our demand. But see that what are the potential on the research, innovation, see the opportunities, liquid electrolytes, solid state electrolytes. If you currently we are using for a solid type of liquid type of liquid electrolytes we are using for the batteries. But if you want to convert the solid state electrolytes, that is a good opportunity for a research perspective. Novel approach, we can say the QC state, solid state electrolytes or electrodes also. Nowadays, electrodes usually, as you know, all the batteries having electrode as a solid content. But nowadays we are using semi-solid or sorry, semi-solid. We can say like that. Semi-solid electrolytes also that developing. Solid state batteries, for example, sodium, lithium is are coming. We are a little bit away from because of availability of lithium is a crisis. Can say that is a sodium phosphates. That kind of batteries also developing. So energy density, for example, this is a theoretical purpose of for understanding. Lithium ion is a 260 watt hour per kilogram. Lead acid, nickel cadmium. These are the range of energy densities here. So these are the about energy storage for batteries here. But water electrolysis coming for hydrogen energy production, this is also one of the emerging technology. Last 3 4 years have been taken this all the industries. They are putting installation. Currently, globally, we can say 300 gigawatts of electrolytic hydrogen production from this in these methods. For example, these methods, or one of that methods we can say, these are the technologies you can say: alkaline proton exchange membrane, anion exchange membrane, salt oxide. These all the technologies almost parallelly maturing, except the anion exchange membrane. If you want to do alkaline water, also alkaline water electrolyzer, around 60% of industrials they preferred for a large ammonia production or any standalone or large industrial requirement they're using. For small requirement and for proton exchange membrane electrolyzers will be used for a small scales or a small scales. That's also 40% contributing for a current commercialized things. Anion exchange is a lab scale. We need a lot of potential to the research on that. There are many groups are working. So solid oxide electrolysis also one of that. See, all the four technology have some merits and challenges be there, but it will be overcome by the recent research. Current trends of advancements is there. So currently, all industry, every day newspaper, if you see any news, science news, if you see that green hydrogen, they're talking like that. Green hydrogen means a water electrolyzer. There is a electrolytic hydrogen we can call. India target is, as you can see, India target it to be around 5 million tons per 5 million metric tons per million per annum by 2030s here. But we need the industrial, if you want to convert as a capacity, suppose that is a requirement, a mass requirement, we need 5 million tons. But if you convert that into electrolyzer capacity, it's need around a minimum 40 gigawatt by 2030s. So usually the electrolyzer capacity will not say about mass base. You can say for the electrical units of gigawatts, we can say. This is an electrochemical device, so we can call about gigawatts in 2030s, keep on increasing. Critical materials, see that nickel, titanium, iridium, platinum. So various critical material records right now, we have to think about how we can achieve that 40 gigawatt, 112 gigawatt by 2040. That we have to think very clearly. We want to do the research on the reduction of these kind of critical materials. Currently, as the efficiency, as you know, that the electrical efficiency, it should be improved. But the recent innovation for this electrolyzer, novel floating electrodes, the one of that trending innovations are going across the world. Higher density should be expected, but you can increase the hydrogen production rate, zero gap, and bipolar. These are that recent innovation on green hydrogen, electrolytic hydrogen, we can say. Another is vehicles, electrical vehicle, hydrogen-based fuel. So this is automobile industries. Right now, we are currently looking IC engine-based. We are using. There are two type of fuel: fossil fuel, petrol, diesel, and compressed natural gas vehicle we are using. So here, some of that companies are emerging the technology. They're using for a fuel cell. Fuel cell means this fuel cell, it's operating, taking hydrogen as a energy input, then converting as a electrical energy. It's converting, it producing, it drive that induction motor. The vehicle is running on the road. So here the fuel cell, we can say the technologies, low operating temperature fuel cell, high operating temperature cell. So automobile industrials are preferring low temperature fuel cells only. Current trends and advancements, you can see that lot of opportunities in fuel cells. You can say catalyst developments, membrane development, durability, longevity. We want to go long way in this way and this thing. India status, recently DST at MNRIM. have funding on fuel cell R&D projects, fuel cell electric demonstrated different areas, and HRS under construction Leh Ladakh recently the conducting. So finally, we want to understand as a researcher, you want to the round trip efficiency. So we are getting electricity, then converting hydrogen through electrolyzer, then hydrogen goes to for fuel cell, then fuel cell is producing electricity. That electricity is driving induction motor. See the round trip efficiency around 42 only. So electricity to electricity we are producing, we are introducing two devices, fuel cell and electrolyzer. This is consuming a lot of energy. So we have to think how to improve the round trip efficiency. Recent innovation is a regenerative fuel cell or reverse fuel cell. This system is generate hydrogen itself and electricity also. That is a dually integrated electrolyzer and fuel cell integrated system here. Next is here CCU. So one of the things our target already we told 1 billion tons per by 2033. What are the technologies? Liquid solvent, solid adsorption, membrane, solid looping, inherent CO2 capture. These are the technologies. Currently, is a liquid solvents dominating amine based. It's a TRL 11 9 used for many industries, fertilizer, soda, natural gas processing by various vendors like that. So here, what are the area to be improved? If we can say the current, what are the improvement to be done? What are the research to be liquid absorption? If you are to think a little bit regenerative, and how to remove the contamination in a very way to operation manual. That you have to check it. Solid absorption membrane, cryogenic, solid looping, novel regenerative absorbent membrane. These kind of things, a lot of opportunities in this area. So we have to look at the trending trends also. This is where another 2 decades we are going to discuss about the carbon capture. CB small modular reactors. This we have to do actually this kind of research only doing from public sector, only specialized. So, however, we should understand what are the things to be in modular small modular reactors. What modular reactor means is a nuclear reactor. Nuclear reactor conventionally 1,000 megawatts we can install, and that is a modular reactor. Small modular means up to 300 megawatts. That is the size will be reduced. This is a potential. This recently BRC, BAR, there are various public sector working on that researches. So biomass and gasification, yes, lot of potential be there. This is a technology, pyrolysis, probe, gasification, filtration. These are the technologies. Feedstock, variety of wherever the biomass, wherever available, so we can use it here. The current trend is, you can see the integrated biorefineries, co-firings, co-generations, energy crop improvements, waste biomass valorization. These are the main criteria for that biomass processing. So recent innovation, we see the jet fuels from industrial waste, algae, turf flow scrubber. This also one of the recent innovation happening across the world. Next, I can show this is I'm consolidating here. I'm consolidating here. Thank you so much. Here you can take it out. Opportunity takes so far we have seen all parameter all the key parameters or key contributor to for energy transition we have seen right now. You can see the solar cell panel, windmill, batteries, electrolyzer, CCU, SMR, biomass. These are the key areas we have seen. In the key area, we have seen what are the technologies, what are the current technologies, what are the demands, and what are the material requirement and current efficiency, what to be done in the future innovations we have seen. See, I have consulted all the slides here, the one slides, target and demands. You can see our Indian demands by 2030 is very nearest to us. Opportunities, see the things. Each opportunities I'm consolidated here. For example, CCU, liquid adsorption, solid adsorption, membrane like that. If you go for batteries, liquid electrolytes, solid state electrolytes, that are mandatory to look for that respective research teams to look it up. Novel approach, already we have discussed, and photovoltaic solar cell, So, bladeless turbine for a windmill, Cauchy state, solid state for electrolytes, electrodes. These are the main criteria today we are taking from this. Thank you so much. This is, if any questions, most I'm able to answer. I'm happy to answer for the questions.
Thank you so much, sir, for enlightening us. Thank you, sir. It will be definitely help us in future. Now, before starting our second session, I would like to introduce our second speaker, Dr. Sushil Saraswat, Professor and Head Department of Chemical Engineering, MBM University, Jodhpur. Dr. Sushil Kumar Saraswat is a distinguished authority in the field of chemical engineering, currently serving as Professor and Head of the Chemical Engineering Department at MBM University, Jodhpur, India. A proud alumnus of Premier Institute, he has completed his PhD from the esteemed Indian Institute of Technology, Delhi. Professor Saraswat area of expertise spans heterogeneous catalyst, hydrogen production technology, and wastewater treatment technology with a key interest in efficient transformation processes. He holds the honor of being a Raman postdoctoral fellowship, during which he contributed to advancement in semiconductor materials for photoelectrochemical water splitting at Virginia Commonwealth University, USA. He was a proud recipient of Indo-Hungarian Educational Exchange Program Fellowship. He has published more than 25 research papers, and he also shared his expertise and insight on various prestigious platforms around the globe, from Oxford University, UK, Virginia Commonwealth University in USA, and IIT Roorkee, India. Now, I would like to invite Professor Saraswat to deliver his talk.
Thank you so much. Uh, I would like to first thank you, Shubharti University, Honorable Vice Chancellor Sir, Major General G.K. Thapiyal, Dr. Shraddha Upadhyay, Dr. Nisha Rana, all head of the departments, faculty members, and dear students. Today, as we are talking about today, I'm going to present my presentations on green hydrogen synthesis and technological advancement towards sustainable energy solutions. As we have already covered some of the portions by Shaktivel, we'll certainly be in touch about what the next current trends in the energy and why it is very important in the current scenario. So our current reliance is basically depend upon fossil fuels such as coal, natural gas, and the energy generations, which is really harmful for our environment too. So the green hydrogen come as one of the great choice in which it is going to shift from sustainable energy resources. As we know that some of the portions also having very interesting about the renewable energy technologies like solar and the wind technology, which is really needed for India and the worldwide, which is significant stride in decarbonization's electrical generations. But however, the addressing sectors such as transportation, industries, and heating or the cooling systems that require innovative solutions beyond the electricity. Why the role of hydrogen in energy landscape? So the because hydrogen is most abundant element in the universe and also hold a great potential as a clean energy carriers. It is also called as the zero emission fuels which produce from the renewable sources. So as a clean fuels, hydrogen offers a pathway of decarbonization sectors that are very difficult to electrify directly, from the such as the heavy industries to the long haul transportations and heating applications. So from this figure, you will understand why the hydrogen is necessity and why it is very important. So you see, this is the excellent energy carrier, which has a great capacity of 142 megajoules per kg of energy required, which is very high compared to the rest of the fuels. It is also has a clean energy with zero greenhouse emissions because when it burns, obviously will come in contact with the air, it is emitting the hot energy and with zero greenhouse emissions, which is a diverse domestic sources. So if you see that many of the sources which are burning right now, or we have in our country, is because of the issues that has produced that some of the industries, like for example in Rajasthan we have NPCL, that's in Kota. So we had to take care whether this electricity that is generated from these places had to be transferred so many places to the Rajasthan and many other states. But the problem is this is not the economical right now. So we need a better security than the commercial fuels. So which is the rightly required is this hydrogen is coming as the best, you can say, the fuel source of the futures. This will give you a glimpse about this is a supply and demand of the requirement of the world in the energy scenario. So in the left hand side, we see that currently we are using these fossil fuels, which mainly consist of the coal and the natural gas from the refinery from the products. If you see what the energy world is seeking in the terms of the renewable energy sources, so we are listed them. So from biomass, solar to hydrogen or the marine energies, these are renewable energy sources which is currently in a world is working on this area, but it needs some of the more research currently. On the nuclear sides, we are working on this area too. Nuclear energy is actually government of India and the many other uh, world energy centers is working on this area. And if you see the bottom of this bottom those figures, so this is mainly used for the portables, transportations, building, and industries. So these are, you will get to know, like these are the area where we really need this portable energy sometimes, because we also want that this energy should be demanded by the industries, small industries. But again, the problem is we cannot generate the energy in a small level at some places. So hydrogen comes with so much of as a importance, yeah, immediate roles to fulfill this demand of the words and the industries as well as the transportation sectors. First, we'll talk about little bit of the hydrogen productions. So if you see that on this sites, this is the fossil fuels that is currently we are using it throughout the world. So
Good morning, sir. Sir, your slide is not moving. I think there is a technical issue. We will join within 5 minutes. Good morning, sir. Now your
morning, there
screen.
was some server
Yes,
error, I
sir.
think.
You can share your screen by going to the
Yes.
present.
So we were talking about this supply and demand. So it will largely require from the industries as well as for the transportation also. Energy carrier which has the large hydrogen the energy capacity, but has a lower production cost. So in this area, we were talking about the thermochemical process. So in the water splitting, this is renewable. Most of the the you can say the most brilliantly used by the industries currently working on this area. Many of the R&D working on this area, which is some of the portions covered by Dr. Shakti will. We are talking about the alkaline PM fuel cell and the solar oxide fuel cells. So there is one other the the sectors which is working on the water spreading through semiconductor. So this is in which the hydrogen or the hydrogen is water is spreading into hydrogens and the on the on the oxygens and the oxygens on which on a semiconductor plates, which will give you uh, the enhanced recovery, you can say. But the problem is it's only having 13.7% of the efficiency current now, so it's not the cost effective process. So if you see that the presently we have a lot of the process we have, so in which if you see that processes, this is steam reforming, partial oxidations, all these processes are there. But the problem with all these processes, they are basically large amount of CO2 is produced in this case. So this is a major disadvantage of this fossil fuel process. If you see that the electrolysis process or the photofermentations or the thermolysis process, that is good thing is they are not polluting any any pollutions from the renewable sources and proven technologies, but they are only the drawback with this, it has a lower efficiency, and so that the higher capital cost is associated with the electrolysis or the renewable energy process. So this will give you an idea about what presently we are talking about this steam reforming process, which is commercially available. You can see that the efficiency of this process is from varying from 74 to 85%, which is normally we are using it, and the mature process 10 town. And but in the renewable energy side, where we are currently working on this area, presently two of the factors which is currently the industry is using is the alkaline electrolysis and the PM electrolysis, which is commercially used in the industries and which gives electricity and water. That means that you need only two things and having the efficiency of 60 to 82% in some conditions, but that has some problems with the other solutions, because this is not commercially viable right now, but some of the research and advancement is currently used it in the different industries. So you can see that what are the production costs of all these methods. So you see that we have already working on steam forming. So you see this is the, if you see the source is methane or the natural gas. So cost per production cost, that's per kg is only 0.75. If you see the cost in the case of electrolysis, that is varying from 2.6 US dollar to 3 US dollars, which is very almost you can say it is 4 or 5 times almost of this the steam forming process. So we need to work out how we can work on this electrolysis process or the hydrogen spreading process, so that we can reduce the cost of this hydrogen process or the green hydrogen process. This will help you to understand why you are basically working on this hydrogen or the hydrogen process. So if you see that currently we are working, or all the world is basically working on this natural gas production and distributions. The problem is associated with the like 25% of the CO2 which is emitted in the environment is basically from these sources. So if you see, if you from use from this area, almost 13.6 kg of CO2 is per kg of hydrogen is produced from this, from this process. So if you compare all these electricity generations, construct and decommissionings, and avoid operations, we can see that large amount of CO2 is generated from only from the hydrogen operation plants, which is very harmful or dangerous for the environment. So everybody start working on this so that we can reduce the CO2 contents on this from this hydrogen production process. Ultimately, we are coming from hydrogens to green hydrogens. Everybody in the world is talking about the green hydrogens. So why we are seeking for the, or why we are going for the sustainable as an alternative of the green hydrogens? So first, the term is green hydrogens, which is solely produced from the electrolysis process, and powered by the renewable energy sources and emitting zero emissions throughout the production process. If you see that we are working on the solar, wind, and the green hydrogen process, which can be carbon neutral, even the carbon negative sides. So this is depending upon the sources. We can easily differentiate because they are green hydrogens. So the key difference from the green hydrogen to the black hydrogen, blue hydrogen, and the yellow hydrogens. So they are distinguishing difference between all these hydrogens. So if you see that black hydrogen is produced when it is produced from the conventional sources of fossil fuels. When it comes to the gray hydrogens, it is produced from the SRM process, but without any carbon capturings, which is significantly of carbon emission is produced from this. So if you see that blue hydrogens, in this, it is from the similar methods, but it is carbon capture in the storage process. If you think about the yellow hydrogens, it is produced through the electrolysis process, which is used from the solar powers. So this will give you an idea. Renewable energy is called the green hydrogens. If we have like yellow, pink, purple, and turquoise is the low carbon hydrogen production process, and this gray on the black is called the fossil fuel generated process, which is the highly emitting of CO2 from this area, and the white is produced from the byproduct of the industrial process. So these are the main classifications of the hydrogens. We will talk about how the green hydrogen is produced from the various methods. So mainly five is, you can say, five methods we are working on this area. So first is the renewable electricity power electrolysis, which is the proton exchange membrane electrolysis and the electron electrolysis. We are not going into detail because Dr. Shaktivel is also covered all these areas and what are the things required for this. Solar power electrolysis, where we need a solar power and is generated, and the energy from the solar is uh, is used in the electrolysis process, and that will help you to produce the hydrogens with zero emissions. Similarly for the wind power and the hydropower, and the last one is biomass powers, which will from the renewable energy sources and produce for the hydrogens in large scale even in the country. So if you see the technological advancement in green hydrogen productions, so continuously research and innovation is going on these sites, but we need certainly an efficient and the cost effective methods so that it can be scalable at the large scale. For this, a large amount of R&D is also required and going on in the electrolyzer design and the material, which is comparatively giving the higher efficiency for converting electrical energy into the hydrogen gases. So unless until we will not scale up this hydrogen productions for the industrial applications, this R&D will, but the R&D is working on this area, which will be helpful for the commercial application of the hydrogen productions. So this is a how we can evaluate this hydrogen productions by the electrolysis. We can say the five parameters or the four parameters, sorry, in which we are talking about the electrode and photomaterial designs. So based on the efficiency of photoelectrode and the photoelectrode materials, if we have the higher efficiency, because right now in the photoelectrodes and the photoelectric materials, which is only efficiency of 17 to 18%, it should be higher in the case of 30%, so that it can be feasibly and the viable for the generation of the hydrogens. Secondly, techno economic aspect should be also covered, because that is usually the cheaply available uh, the technology, so that it can be economy viable for all the industries can working on this area and use this the hydrogen generation technology for their implementations. Definitely one of the important factor is the environmental aspects. So one good things about the hydrogen generation from the renewable energy is it has a zero emissions technology. So when we are working on this zero emissions, certainly we are on always on the positive sides. We are not going for the negative aspects of the environment. So it is always in the case of renewable energy sources or the water electrolysis for the green hydrogens, it is the most important and the environmental friendly techniques is usable. So we are working, or definitely the various industry and the various country is working on this area, where the case study is being taken how much of electrolysis is used for generation of electrolysis of the green hydrogen from various sources. We can take in one good examples how the recently use of ammonia cracking by this hydrogen process and for the commercial scales. So if you see that if we are taking this help, so from the renewable energies, it is the hydrogen, the energy or the electricity is generated, and this electricity will help you for the for ammonia productions, and this electricity is converted to the renewable energy, it is converted to hydrogens, and this air is using for the air distillations, which is forming ammonia. So this ammonia is again storage in some storage plants, and then through the transportation wherever you requires. So this hydrogen is through thermal methane decomposition, ammonia decomposition process is again converted to the hydrogens, which is going for the refuel stations, and you can be used for the domestic and the transportation purposes. So that is overall scenario shows that we're starting from the renewable energy to end of this process, everything is zero emission process. So, though in details, my previous research has already talked about the physical and the metal-based, hydrogen stores. So they are physical-based, so compressed air, cold compressed, or the liquid hydrogens. And the metal-based is currently working on the different kind of metal hydrides, which is adsorbent, liquid organic, and the chemical hydrogens is completely and the complexly hydride is used by the various industries for the efficient hydrogen generation, hydrogen storage. Transportations in the fuel cell is currently by the various industries. Even the Ministry of Renewable Energy is working on this area, which is presently working on the different zero emissions transportation sectors. You can see even from Tata to many of the currently transportations industries working on e-cars, e-buses, and e-sectors, which will definitely have a positive effect on the environment. The energy storage has the excessive energy, renewable energy. So electrolyzers, which is convert this energy to the hydrogens, which can be stored later on the back to the electricity wherever it is required. The another important point is the grid balancings. So it has a flexible and dispatchable energy resources and supporting the grid stability and balancing this intermittent renewable energy sources like solar and wind powers. If you see the industrial process where it is required is, as we have already covered, the ammonia production process, refineries and petroleum, steel manufacturing, power generations, heating and cooling systems, where this green hydrogen will help you or help the industries to providing reliable electricity from the renewable hydrogen energies. On the left hand side, if you see that we are the very pros, you can say the advantage of the green hydrogens, it is 100% sustainable because it is non-renewable, formed from the non-renewable sources. It is storable, it is versatile, can be used as in a small amount at various certain places, and it is transportable. But the advantages currently, which is working on the various agencies on, it has a higher cost, the energy consumption is very high, and the safety concern is also a big issue for the environment, for the transportations and the consumptions. So we have already think about it because it is environmental friendly, so can be used. It gives a job opportunities for the innovation, economic growth, and energy sources is, you can say that one of the sectors where India needs energy security. So it will help the energy India to having good energy sources and reduce the dependency on the fossil fuels. So green hydrogen has some, as we have already talked about the promises and challenges, because hydrogen or the green hydrogen is basically decarbonization plants of many countries, which include green hydrogen because of the combustion hydrogen release only heat and streams. India has a 60% of energy comes from the fossil fuels. So if India has targeted in 2030 to reduce this, going to be 60% from the vice versa or the renewable energy process. But at present, we are working on the electrolysis of water, where research is going on, and DST, MNRE, and many of the big centers they're working on how we can use this energy to provide this to the various sectors of the at the commercial and the lower level of the uh, of the industries. But currently, as we are talking about, it has a significant problems because of the uh, presently of the less economical in these areas. If you see that this is smaller case study of the steel sectors. So currently, steel sectors requires or in like the energy consumption is 33 exajoule. So if we are seeking this target, like for example in 2050, so in three sectors we can definitely work on. First is the innovative design resources, which is need to produce new factors or the new products which less the energy requirement by 20.6 exajoule. So if you compare that, by 1.5 degrees C aligned this steel sectors, if you compare this from the 33 exajoules, so 25.5 exajoules of the energy we can reduce it by working on this three area. So we can use it circularly reduce need for the new steel and the redesign process for the most efficient production process. So we are here today. So like for example, we are in 2024. So if you see that the hydrogen production timeline, which is ready to deploy in by 2027, 2047, Ministry of Transportation is working on this area. So as we have already known that some of the medium and the large size of vehicles of the car basically working or start working from this hydrogen energies, which is even the train is Ministry of Railways also starting working on this area. So we are on this age where medium size of car the vehicles we are using it from the green hydrogen energy. If we are going to reduce these powers and having these implementations, definitely we will work on the 2024, where we can say like after 100 years of independence of India, we are converting this whole fossil fuel to the renewable energy sectors of the country. So it will basically less dependency on the fossil fuels. So we are basically use the hydrogen as a fuel of the energy carriers, which has provide the national strategic goal. First to complete is energy security, environmental security, and international competence. So that will cover all three aspects where this goals is immediately requires to approach this, and we can certainly by covering all the sectors, we can be sure that India can be having this energy security by 2047. So you see that the green hydrogen missions is silently working. So basically R&D is working, R&D in public and private partnership or hydrogen partnership start working. You can see even the small and the pilot scale plant sectors like in steel and the heavy industries working on this storage and shipping is also working. Uh, Pradhan Mantri Modi ji has also worked on the cluster-based production and utilization model for enhanced viability of hydrogen energy products, which is the national vision process. And you can see that enable policy also framework on the green hydrogens and the emission process. So basically, we are moving towards the sustainable mobility, where the green hydrogen-based society is working on the auto manufacturers, working on the university and the technical schools, because IIT and NIITs and the many of the research organizations are working on this levels where the human resources or the HRD is working. How we can reduce the hydrogen production plants process can be renewable energy sources through the renewable energy sources, and how it can be stored and the technology and what the basic research is working on. So R&D is also working in this area. If you see that the general public of this is society, so we need a public awareness how we can go for from like fossil fuels to the hydrogen energy based societies. So fuel energy as we have already talked about it, fuel industry is working on the hydrogen production, distributions, hydrogen storage technology. So, but requires a basic infrastructure which is going to be covered maybe in the coming years. So, the government has a mix, you can say, the uh, strategy and having codes and the standards for green hydrogen productions, so that it can be win-win situations for the environmental as the and as well as the India. So I can say that hydrogen, or you can say the green hydrogens, is one of the promising technology and the most viable uh, hydrogen energy you can say the clean energy carriers for the near futures. But simultaneous research work is improvement on the hydrogen production efficiency and technological suitability is required, so that it can be good viable options for the industries. This is definitely energy provides CX-free hydrogen emissions technology and technological advancement with less hydrogen only possible when it is used to the non-renewable energy hydrogen production technology. So thank you so much from my side. I will be help. Thank you. If you are having any questions from this technology, or you require any questions, please let me know.
Thank you so much, sir, for enlightening us. Now the session is open for discussion. If no question, then we can move further. Thank you so much, sir, for your
Thank
valuable
you,
speech.
Doctor. Thank you, Nisha, and thank you so much.
Now, I would like to thank Honorable Vice Chancellor sir for permitting us to organize this webinar. I also want to thank all deans, directors, principals, HODs, faculty members, scientists, and participants for taking their valuable time out and ensuring their presence here. I also thank the organizers, especially the event chairperson and co-chairperson, convener and co-convener of the webinar. I would like to thanks to all speakers. We are also thankful to the media section, Mr. Subham Kaushik and IT team from Bharati University. Without them, this webinar would not have been possible. I hope we will be conducting offline seminar and invite you all in future. Thank you all. Jai Hind.